Alaikum wa rahmatullahi wa barakatuh. Students, today we shall start exercise 9.2, the second exercise of the chapter areas of parallelograms and triangles. Let's have the first question of the exercise. Question says, question number 1, in the figure, this is the figure which is given. In the figure ABCD is a parallelogram. In this figure, question says this figure is a parallelogram. ABCD is a parallelogram. AE is perpendicular to DC. AE is perpendicular to DC. See? And CF is perpendicular to AD. CF is perpendicular to AD. If AB is equal to 16 centimeter, now AB is equal to 16 centimeter. This thing is 16 centimeter. AE is equal to 8 centimeter. AE, this much, is 8 centimeter. This is 8 centimeter. CF is equal to 10 centimeter. This thing is 10 centimeter. This is 10 centimeter. CF. Find AD. You need to solve for AD. Solve for this AD. You need to find AD. Let's write given. What is given? A parallelogram ABCD. A parallelogram ABCD in which AE is perpendicular to DC, CF is perpendicular to AD, AB is equal to 16 centimeter, AE is equal to 8 centimeter, AE is equal to 8 centimeter, and CF is equal to 10 centimeter. This is all given. To find, what we are going to find? We are going to find length of AD. AD is what you are required to find. Now solution. See what I'll do. We just proved in the previous lecture that area of parallelogram is equal to base times corresponding altitude. You know that very well, that area of parallelogram is equal to base times corresponding altitude. So if I take ABCD as parallelogram, and if I find area of this parallelogram taking DC as base, then I need to take AE as altitude. Now corresponding altitude means if you take DC as base, then AE would become your altitude. If you take AD as base, CF would become your altitude. So since area of, now if AB is 16 centimeter, this is also 16 centimeter, because opposite sides of parallelogram are equal. Since area of parallelogram, area of ABCD is equal to base times corresponding altitude. If I take DC as base, then I need to multiply the corresponding altitude, and for DC, AE is the corresponding altitude. Got it? Okay. Which is equal to DC is how much? DC is 16 times AE is how much? AE is 8 centimeter. It's already given. AE is 8, it's given. DE is 16 because opposite sides of a parallelogram are equal. So 16 times 8. 16 times 8. Here you can write the reason as AB is equal to DC. This is your reason here. Now it's 128. 128. Now area units are centimeter and area is in square units, so it's square centimeter. So you got your area of triangle ABCD as 128 square centimeter. Okay. Also, area of ABCD, you can also find area of ABCD by taking AD as base and CF as corresponding altitude. So in that case, we'll get AD times corresponding altitude. For AD is CF. So, which implies that now area of ABCD is already known now. It's 128. So I write 128 as area of ABCD because we just found that area of ABCD is equal to 128 square centimeter. Is equal, right? AD as such, then times CF is, again we know CF. Where is CF? CF is 10 centimeter. So I write 10. Then dividing 10 throughout, you'll get 128 divided by 10 is equal to AD. So in that case, therefore, AD is equal to 12.8. 12.8 centimeter. And that's your answer. Got it? Make a note. You can pause the video to make a note of this question. By using the previous formula, I told you in the previous lecture, by using the previous theorem first, that parallelograms on the same base and between the same parallels are equal in area, and using the corollary that a rectangle and a parallelogram on the same base and between the same parallels are equal in area, you can prove different formulae, like you can prove area of parallelogram is equal to base times corresponding altitude, which we already did. You can prove area of triangle is equal to half times base times corresponding altitude. You can prove area of rhombus as well, 1 by 2 times product of its diagonals. You can prove area of trapezium as well, 1 by 2 times sum of parallel sides times altitude. So these are the formulae which you can prove by using that theorem first. Give that a try, it's very easy. Give it a try. I showed you the first result, and similarly you can move on to these 3 results as well. Now let me show you one more question. Let's have question number 2. Question number 2, question number 2 says, if E, F, G and H are respectively the midpoints, if E, F, G, and H are respectively the midpoints of the sides of a parallelogram ABCD. Show that area of EFGH is equal to half of area of EBCD. So question basically says, I'll make a figure directly. You have a parallelogram ABCD. So let me draw a parallelogram ABCD. A, B, C, D. If E, F, G, H are respectively the midpoints of sides of a parallelogram. E, F, G, H are the midpoints. So E is the midpoint. A, B, C, D is a parallelogram. E is the midpoint of AB. F is the midpoint of BC. G is the midpoint of DC. And H is the midpoint of DA. It is given. So I write given a parallelogram ABCD. A parallelogram ABCD in which E, F, G, and H are the midpoints of sides AB, BC, CD, and DA respectively. Got it? Show that. Now you need to prove area of EFGH. Area of EFGH. Area of EFGH. Area of EFGH is equal to half of area of ABCD, is equal to half of area of ABCD. So basically you need to prove, you are given with a parallelogram ABCD in which E, F, G and H are the midpoints of this side, this side, this side and this side respectively. Now all you need to do is just prove that this EFGH, now EFGH is a quadrilateral here, so prove that area of EFGH is half of area of ABCD. This quadrilateral, area of this quadrilateral, the middle quadrilateral, is the inside quadrilateral rather, the area of this inside quadrilateral is half the area of full parallelogram. Got it? Now, what I do, I'll go like this. Let me join H, F. Let's have a construction. Join HF. Join HF. Now let's have the proof. Understand one thing before we understand this question. If you have a triangle, and a parallelogram, If you have a triangle and a parallelogram, say ABCD is a parallelogram and ABE is a triangle. Now consider ABE and ABCD parallelogram, triangle and parallelogram. These two figures share a common base, and which is that common base? AB. And both the figures lie between the same parallels. Now I hope that you already know what is the concept of between the same base and on the same base and between the same parallels. You know that in advance. So ABE is a triangle and ABCD is a parallelogram. This triangle and parallelogram share a common base, that means they are on the common base and between the same parallels. So therefore here we have one more result, that is area of ABE. Now if this is a case that a triangle and a parallelogram are on the same base and between the same parallels, then at that time area of triangle is always equal to half of area of parallelogram. As in this case, area of triangle is equal to half of area of ABCD. It would be always true. If two parallelograms are on the same base and between the same parallels, their area is equal. If triangle and a parallelogram are on the same base and between the same parallels, then area of triangle is equal to the half of area of parallelogram. You can prove that easily. See to the construction like this. Make a parallelogram out of it. Say this is F. Now ABFE is also a parallelogram. Okay. Now you can do one thing. Make this one parallelogram out of it. So you can prove that ABE, area of triangle ABE is equal to. So make a parallelogram out of it. Then do one thing, make this triangle and this triangle congruent. Now by doing that, you will easily get that area of ABE is equal to 1/2 area of ABCD. I'm just reminding you this, we are already done of this theorem. You can check the previous video where we have proved that area of triangle when triangle and a parallelogram are on the same base, then area of triangle is half the area of parallelogram. Having said that, what we have now, so using the same logic, if you pay close attention, in parallelogram ABCD, in parallelogram ABCD, what you observe one thing, that since AB is parallel to DC, since AB is parallel to DC, AB is parallel to DC. Reason is opposite sides of a parallelogram opposite sides of a parallelogram. Then I have then I can do one thing, that HF and see AB is parallel to DC, opposite sides of a parallelogram. I have one more thing, this side is also parallel to this, so AD is parallel to C, AD is equal to BC. Same reason, Opposite sides of a parallelogram. Opposite sides of a parallelogram. Which implies that AD is equal, then I can say half of AD is equal to BC. What does that mean? Is equal to half of BC, sorry. Is equal to half of BC. You know, when wholes are equal, halves are equal. Which implies that then half of AD is nothing but DH. Why? Because H is the midpoint. Since H is a midpoint and half of AD is HD, so I can write HD is equal to half of BC is nothing but FC. Now see, HD is equal to FC and HD is parallel to FC as well. HD is also parallel to FC. Why? Right, therefore here, and HD is also parallel to FC because AD is parallel to BC, as AD is parallel to BC. Got it? Because AD is parallel to BC, that means HD is a part of AD. If AD is parallel to BC, that is implied, then it's implied that HD is also parallel to FC. Okay. By these two, what we get, then you get HFCD is a parallelogram. HFCD is a parallelogram. Then HFCD is a parallelogram because opposite sides are equal and parallel. When in a quadrilateral opposite sides are equal and parallel, then that very quadrilateral is a parallelogram. So HDFC is a parallelogram. Now we have also a triangle GHF. Now this triangle and parallelogram are on the same base and between the same parallels. Therefore area of triangle is equal to half of area of this parallelogram. You make a note of this. I'll drop it out. Pause the video. So there is no need to write this thing. No need to write this. Don't write this. Just start directly from this point. Since AD is equal to BC in parallelogram ABCD, since AD is equal to BC, opposite sides of a parallelogram. Got it? There is no need to write that one. Now make a note. Since in parallelogram ABCD, AD is equal to BC, AD is equal to BC, opposite sides of a parallelogram, then it follows the wholes are equal, halves are equal. That is, half of this is equal to this. Here I can write as H and F are midpoints. H and F are midpoints. Here you can write this as H and F are midpoints. Okay. Now make a note. Now see, HF, we proved that HFCD is a parallelogram. Now triangle GHF and parallelogram HFCD. Triangle GHF and parallelogram HFCD share a common base, which is the common base of these two figures, HF, and lie between the same parallels. And both the figures lie between the same parallels, as HF is parallel to DC. Now we proved that HFCD is a parallelogram. If it is a parallelogram, then obviously HF is parallel to DC, opposite sides of a parallelogram. Same parallels as HF is parallel to DC. Therefore, you can make the result area of GHF is equal to half of area of HFCD. HFCD. Got this point? So far, we proved that area of GHF, this triangle, is equal to half of area of this parallelogram. Now, having said that, similarly, you can prove that area of this triangle is equal to half of parallelogram this, ABFH. Can't we? Yes. How? Because again, this is, you can do now, you can take this portion of half, what we did earlier, half of AD, we took HD, you can take HA instead now. Got it? So, similarly, area of triangle EFH is equal to half of area of ABFH. ABFH. Now, call it first and call it second. Now just add first and second. Adding first and second, we get this plus this is equal to this plus this. Area of GHF plus area of EFH is equal to half of area of HFCD plus half of area of ABFH. Area of 1 by 2, area of this plus this, because it is, when you are adding two equations, you add left hand side to left hand side and right hand side to right hand side. Now GHF plus EFH, GHF, this one, plus EFH, this plus this is nothing but EFGH. See, this plus this is EFGH. So add this and this, you get, therefore, which implies that, so this plus this, you get area of EFGH is equal to 1 by 2. Take 1 by 2 out as common factor, so area of this plus this, HFCD plus area of ABFH. Got it? Just like this. Therefore, area of EFGH, is nothing but 1 by 2 times this plus this. Now see, HFCD, HFCD, this parallelogram, plus ABFH, ABFH. Now adding this, and this. Area of this and this is nothing but area of parallelogram ABC D. See? Good. 1 by 2 area of ABC D. And we proved what we were required to prove. Area of EFGH is equal to 1 by 2 area of ABCD. Area of EFGH is equal to 1 by 2 area of ABCD. Hence, proved quadrilateral demonstrandum. Make a note. Now I will leave question number 3 and question number 4 to you people. Give a try to question number 3 and question number 4. Very easy, similar to the previous questions. Now I'll show you question number 5. It's again very easy question. Now see, question says in the figure, this is a figure, PQRS and ABRS. Again, PQRS and ABRS are parallelograms. These are two parallelograms. It's given that both the figures are parallelograms. And X is any point on side BR. X is any point on this BR. Show that, you need to show that this is equal to this and this is equal to this. So I wrote given the same thing, two parallelograms PQRS and ABRS share a common base. But what I wrote given here, I wrote that they share a common base. If you observe carefully, PQRS and ABRS, they indeed share a common base, and that's RS. Got it? So RS is a common base shared by both these parallelograms. You need to prove area of PQRS is equal to area of ABRS. Number 2, you need to prove area of AXS is equal to half of area of PQRS. Now first of all, we proved first thing, that is PQRS is equal to ABRS. Consider parallelograms. Consider these two parallelograms. What you are going to prove, consider these two parallelograms PQRS and ABRS. If you observe carefully, PQRS and ABRS, they share a common base, and that's RS. That's what I wrote. Consider parallelograms PQRS and ABRS. These very figures share a common base, SR, and lie between the same parallels. And these two figures lie between the same parallels. Why? As SR is parallel to PB. Because if SR is parallel to PQ, opposite sides of a parallelogram, and SR is parallel to AB, opposite sides of a parallelogram, that means SR is parallel to the whole PB. Therefore, you conclude that the areas of these two parallelograms are equal. So, area of this is equal to this. So, you proved the first thing. Then for next, consider AXS and ABRS. Again, these very figures share a common base, ASC. AS is present in AXS triangle, and AS is also present in ABRS parallelogram. So I can say that area of triangle this and parallelogram this share a common base. Triangle this and parallelogram this share a common base, AS, and they definitely lie between the same parallels, as AS is parallel to BR, opposite sides of a parallelogram. Therefore, you conclude that area of triangle is equal to half of area of parallelogram. However, area of ABRS is equal to PQRS. You just proved PQRS is equal to ABRS. That means replace ABRS by PQRS, so you get area of triangle AXS is equal to half of area of PQRS. That is what you were about to prove, you were required to prove. Area of AXS is equal to 1 by 2 area of PQRS. Hence proved. Make a note. Now let's have the last question of this exercise. Now question says, a farmer was having a field in the form of a parallelogram PQRS. She took any point A on RS and joined it to the points P and Q. A farmer was having a field. There happens to be a farmer who was having a field in the shape of a parallelogram PQRS. Let's say this is a parallelogram. This is a parallelogram shaped field of a farmer named PQRS. PQRS. She took any point A on RS. On RS, she took any point. So take an arbitrary point A. Arbitrary means take it anywhere on SR or RS. Take it anywhere. So let's say I took it here. That's what she did. She took any point A on RS and joined it to the points P and Q. Then joined it to P and joined it to Q. Joined the same point to Q. In how many parts the field is divided? Now answer the question. In how many parts field is divided? 1, 2, 3. So answer for first part, 3 parts. What are the shapes of these parts? Yes. What are the shapes of these parts? Triangles. All of the 3 are triangles, isn't it? Then the farmer wants to sow wheat and pulses in equal portions of the field separately. How should she do it? She wants to sow wheat and pulses in equal portions. So she has wheat. Let's say W stands for wheat. And she has pulses. Let's say P stands for pulses. She wants to sow it in equal portions. That means for wheat, the amount of land for wheat must be equal to the amount of land for pulses. Got it? Now area of land in which wheat is sown must be equal to area of land in which pulses are sown. So simple. See, triangle and a parallelogram. APQ is now what? It's a triangle. And PQRS it's given, it's a parallelogram. Now triangle and a parallelogram share a common base PQ. And they lie between the same parallels, as PQ is parallel to SR, opposite sides of a parallelogram. In that case, you can easily conclude that area of this triangle is area of, you can conclude easily that area of APQ is equal to half of area of PQRS. Can't you conclude that? Yes. So that means if she will sow wheat in triangle PQ, APQ and pulses in this triangle and this triangle, area of triangle is equal to half of this. That means area of triangle is equal to this plus this. You can conclude here area of APQ is nothing but area of ASP plus area of ARQ. Isn't it? Because area of triangle is half of area of parallelogram. Now if half is this, the remaining half of parallelogram is this plus this. So she will sow pulses in this and this and wait in this, or she can do vice versa. Vice versa means pulses in this and weight in this or this. So hope I made you understand this thing. So by this, alhamdulillah, we are done with this, with the second exercise of areas of parallelograms and triangles. So inshallah, see you next time in next video with some new stuff, inshallah. Till then, take care and do remember me in your supplications. Assalamu alaikum wa rahmatullahi wa barakatuh.